des animations, mais il n'y a pas de vidéo.
Ok, d'accord. Bon, bah, là, on est bon. Donc, pour le micro, il y en a un enfin, on va coller au micro pour avoir une voix et en scène.
Yes. Ça marche. There's a...
Yeah, let's just go right.
Okay. Can I put the presenter mode or...
What's that?
The presenter mode.
Wait, say it again.
Wait.
C'est quoi déjà notre présentation?
This. Does it work? No, it doesn't work. Okay.
Tu veux les deux, tu veux en étendre?
Bon, c'est pas très grave, en fait, je sais ce que je vais raconter.
Ok, parce que sinon, après, on a le... Je crois que c'est FNF8, à mon avis.
Non, mais je vais me débrouiller.
Ouais. Ok.
Are you talking about the timer?
Yep. That's the presenter mode, you have your notes in.
Oh, okay.
It's not... C'est pas si important. Ok.
Donc juste d'attendre la confirmation, c'est bon. Ok.
So, hi everyone. I'm Léonard Lys. I'm a researcher at the Laboratoire d'informatique de Paris 6, which is on the Jussieu campus just a few blocks away. And I'm also a consultant at Palo IT. So today I will present you my work on atomic crunch chain swaps and how to enhance them with relays and adapters. It's kind of funny that I'm doing my talk right after Alexei, because he's stating that you can't do HTLC without a TTP, and I'm stating that maybe you could. So, a few words about my company. We are an international consultancy company based in Paris, but we operate in 7 countries, and we have 400 experts ranging from developers to PO and designers. 1 year ago, we founded with my colleague Arthur a blockchain unit inside our company, and we have 2 main focus, which are interoperability and UX in dApps, because in our point of view, those are the 2 main pain points for blockchain mass adoption. So yeah, as I said, our skills range from research to development, as I'm a researcher and a PhD candidate, but we also have developers and the partnership with the laboratory. And finally, we are the proud host of the DeFi meetup, which is in our office in Paris every 2nd Thursday of the month. So yeah, please come by, it's very fun. Okay, so let's dive in. An atomic cross-chain swap is basically a trustless transaction between 2 parties swapping assets on 2 different chains, like trading Bitcoin for Ethers. There are 3 main atomic swap strategies. You have centralized and multi-signatory schemes. Those are what centralized exchanges are doing. You need a trusted third party. You have sidechains and relays and hash time locking. So I will be talking about sidechains, relay, and hash time locking. So what are hash time locked contracts? Basically, it's a simple commit reveal protocol. You lock a coin inside a contract, and this coin can be unlocked by the initiator, but only after a certain amount of time, or by the participant, but only if he's able to provide a secret S that has been generated by the initiator. So how does the protocol looks like in general? So you have Alice, Bob, you have blockchain alpha, blockchain beta, and the first step is that Alice generates a secret S and computes its age. Then she sets up an HTLC contract on the blockchain alpha. The transaction goes from Alice to Bob. The amount is 1, the secret is the one she computed, and the lock time is tomorrow at 6:30. So, as you can see, they have to settle a price off chain. They have to to meet off-chain and to do lots of processes off-chain. Then once Alice has set her HTLC, she will send to Bob the ID of the transaction, and Bob will parse the Alice's transaction to verify the lock time, the amount, and the secret, the hashed secret. So he will copy the hashed secret and set up himself an HTLC on blockchain beta. So transaction goes from Bob to Alice, the amount is 1, the hashed secret is the one he just copied, and the lock time is tomorrow at 5:30. As you can see, the lock time of the second contract is inferior to the one on the first contract. That's to prevent Alice to do a kind of double spend attack on Bob. I'll come back later to this delta of time between both lock times. At this point, both contracts have been set up, and it's time for them to redeem the contract. So Bob will tell to Alice off-chain that the contract is ready. So Alice will sign the transaction and provide the secret. By doing so, she will unlock the coin and receive it, but she will also reveal the secret to Bob. Now that Bob has the secret, he can go to Alice's HTLC, sign it, provide the secret, and redeem the coin. So that's how the scenario looks like when everything's okay. But if at any point of the protocol, any of the participants stops acting because the node crashed, because they don't want to swap anymore or anything, they won't unlock the coin, and to be refunded, they just have to wait for the time lock to expire and sign the transaction and be refunded. Okay. So to sum up, an atomic swap is a protocol that guarantees that any honest participant that complies to the protocol will not end up worse off. But the problem is that a node crash happens, network overload happen. So you also depend on the livability of your client, and this cannot be ensured. That's why some are stating that you need a trusted third party to do an atomic cross-chain swap with HTLC. Then another problem is that HTLC atomic cross-chain swap are as slow as the slowest blockchain involved in the trade. Meaning that I told you about this delta of time. The second HTLC lock time has to be inferior to the first HTLC lock time. And the delta between those two lock time has to be significant compared to the block time of the slowest blockchain. So for example, for Bitcoin, it's reasonable to assume that you need at least 6 confirmation. 6 confirmation meaning about an hour. The delta of time has to be significant compared to 1 hour. So maybe like 2 hours, meaning the scale of time of an atomic cross-chain swap is huge. Then another trade-off is that it requires the participants to be online and to execute lots of tasks. Well, if a client crashes, the participant will end up worse off. So that's a second trade-off. Then, because of the high numbers of transactions, you have to do at least 2 times 2 means 4 transactions. So you have to pay for 4 transaction fees. It's not competitive compared to the exchange's fees. And finally, the participant's blockchain node is a single point of failure. So why am I doing still atomic swaps? Because HTLC atomic swap can be combined with other technologies such as relays and external adapters. and I'm not the one saying it. It's a quote from God himself. He states in a paper that hash locking can be combined with relays. So on the right, this is a very naive sequence diagram of an atomic swap. And what we do want to improve is allow for decentralized order matching, because on this diagram, you can see that both parties agreed on the price off-chain prior to initiating the swap. So first thing we want to do is allow for decentralized order matching and decentralized order book. Second thing we want to do is automate auditing, because auditing a contract is a pain in the ass, and it requires some technical skills, and a naive user do not have the skills to do that. And finally, we want to reduce the amount of user actions to only one. We want to be competitive compared to centralized exchange platforms. So in a centralized exchange platform, you just place your order and wait for it to be completed. So we want the user experience to be as good as in a centralized exchange platform. So first, how do we do to allow for decentralized order matching? Well, on this screen you have two HTLC interface. The first one is the HTLC interface of the naive protocol of this sequence diagram. It does not allow for decentralized or on-chain order matching, because you have to set up the participant address when you initiate the swap. But with the second interface, with this enhanced interface, you initiate the swap, so you lock the coin before setting the participant. So it's trivial to say that you could make an order matching contract that will parse the HTLC contract for open trade. You can make an interface, and then people will just have to call this or this transaction in order to initiate the swap. Okay. Then the two other things we want to improve is automate auditings and reduce the amount of user actions. So to automate auditing, we will make use of relays, and to reduce the amount of user actions, we will use what we call adapters. So I will tell you what's my definition of relays and adapters. So to me, a BTC relay is, as explained Alexei earlier, is a smart contract that has light client capabilities. So for example, a Bitcoin relay on the Ethereum blockchain is a contract that allows you to read the state of the Bitcoin blockchain from the Ethereum blockchain. It works by publishing block headers of the Bitcoin blockchain inside the Ethereum blockchains. And then you have a smart contract that does the cryptography of verifying transaction, and it's totally feasible to implement an interface for developers to hide the complexity of the cryptographic functions. Then adapters is a service mounted on a blockchain node that lets you access to off-chain data and to access off-chain's API. Here is a little scheme of the architecture of Chainlink external adapters. So the red arrow here means that this connection is authentified. So the data that is here can be sensitive data. For example, you could totally imagine putting the secret and the hash of the secret inside of this external adapter. You could also put your Bitcoin and Ethereum private key in order to be able to sign a broadcast transaction from the adapter, etc., etc. So here is the sequence diagram of my proposal. The real sequence diagram is more complex because you have several adapters and several relays. Actually, you have 2 adapters and 2 relays. So to simplify it, I do as if there was only one of each. But this side is blockchain A, the other side is blockchain B. Okay, so remember the relay is able to read the state of the other blockchain, and the adapter is able to sign, generate, and broadcast transaction to both blockchains. The relay is a smart contract, and both HTLC hosted on chain A and chain B are also smart contracts, so they can totally communicate and call each other. Last thing, the adapter is as a part that is off-chain, so you can totally make cron jobs or triggering transaction. This is totally feasible. And the adapter also has access to a node because it's mounted onto a node, so it can broadcast transactions. So how does it work? Alice, if she wants to initiate a transaction, instead of calling directly the HTLC that is hosted on chain A, she will call the adapter. The adapter will generate the secret, compute the hash of the secret, and store it inside some protected data store. And the adapter will call the HTLC with the generated parameters. And the open transaction, the open swap, will appear on a decentralized order book. Bob has access to this order book and can totally call for this trade. And then the adapter, when Bob calls, will verify that Alice's transaction is correct. So it verifies the parameters of Alice's transaction. It verifies the lock time, the amount, etc., etc. The relay sends back to the adapter the transaction parameters, and it triggers. And if the transaction parameters are okay, the adapter triggers the HTLC on the other chain and initiate the swap. Then, when the swap has been initiated, the HTLC on the blockchain B will return the transaction parameter. And at this point, the swap has been initiated. Both coins are locked on each blockchain, but the participants have not been set yet. So the adapter will call a request set participant to the HTLC on blockchain A. The HTLC will call the relay. The relay will verify the parameters, and if Bob's HTLC has been correctly set up, then it will actually set the participant on the other HTLC. Then you have exactly the same procedure for Bob's contract. So requested participant, he verify in the relays that the transaction is okay, and if the transaction is okay, he actually set the participant, saying that Alice is the participant. Finally, last stage, everything is set up, the participants are set up, the coins are locked, everything is okay. So the adapter will send to the HTLC on blockchain A a request redeem to request Alice's contract to unlock Bob's coins, and doing so, revealing to Bob the secret. Well, to Bob's adapters. And same process with the redeem. It sends back the secret right here, and Bob's adapters will withdraw the coin. So with this protocol, by combining relays, adapters, and hash time-locked contracts, you can totally do an atomic swap with only one user action. But, well, there are quite a few limitations and cons of this protocol. Well, for the moment, it will require you to run a node and an adapter. That's quite heavy in terms of infrastructure. But I've been discussing with some Chainlink guys, and they are working on a trusted environment, a trusted execution environment that could allow you to mount your adapter on someone else's node without fearing that he could see your Bitcoin key or your secret. Second problem is that it's still as slow as the slowest blockchain you are using, but it could totally be plugged to any layer 2 scalability blockchain. And last thing is it's still vulnerable to the ghost attack. It's when a participant considers that the swap is not profitable to him anymore, so he stops the protocol. But you could prevent that by making a little fee when you initiate a transaction that is refunded if you go to the end of the protocol, but that is burned if you don't finish the protocol. Okay, so, well, that's it. Feel free to reach out if you have any questions.
Oh yeah, if anyone has any questions.
Volunteer actually.
Wait, anyone have any questions, I guess?
So basically the idea is to create an order book where you can execute cross-chain atomic swap transactions, let's say.
Mm-hmm. Yeah.
And okay, so I didn't really get how do you set the receiver after you already created the HTOC? Isn't this some point of failure? Because you said that this is the upgrade. You don't put the receiver in the initial creation of the swap,
yeah,
but you add it after that. Who is adding it? And can this be corrupted?
No. Well, if you think about a Solidity-like environment, it's, well, you can say, you can give, okay, each swap is a structure, and each swap has parameters, and each swap has a state. Okay, you can tell that if the swap state is called initiated and not open, then the coin can move, can't move. Like you put modifiers. You put a modifier that states only initiated swap or only open swaps. That's totally feasible.
Okay, but it should be two parties or one party, third party, which is verifying the parameters on Bitcoin side, on Ethereum side, and if everything is fine, then it is using this modifier to set the receiver on Ethereum side. And
yes, that's
okay,
it.
but which is the third party? I mean,
no, there's no third party. I think the third party you're thinking about is the relay.
Yeah, the relay.
The relay is like a lightweight client hosted on blockchain B that has lightweight client capabilities on blockchain A. It works by publishing blocks of blockchain B inside blockchain A. Then you can make a smart contract that has the same cryptographic capabilities than the blockchain A, and you can verify and decode transactions that are on blockchain B from blockchain A. Okay. See what I mean?
Maybe we can discuss it after that.
With a relay, you can read the state of another blockchain from one blockchain.
Okay.
Okay, so you can submit to the relay a transaction from another blockchain and ask the relay, is this transaction a real transaction, and what are the parameters of this transaction?
Okay.
So you can verify that the lock time is okay, that the amount is okay. You can verify that you can do the auditing of the transaction directly on chain.
Okay, that's super cool.
Yeah.
And one last thing, you can modify the swap structure on the Solidity side, but how can you do it on the Bitcoin side? Because Bitcoin script is a little bit limited, and I'm not sure if you can do this.
You can do this. I'll send you my GitHub. There's an implementation of this.
Okay, super.
Anyone else? All right, another clap, I guess.
Thank you.
All right, cool. And Alex, I guess. That's at 12:30 though. Yeah. It's around here. Yes, the next speak is at 12:30. Sorry, yeah.